All right, guys, we are on to finding area of triangles. When you were in geometry or well before that, if you knew the height of a triangle, whether it was a right triangle or not, there was a formula for area that was base times height divided by 2, or 1/2 base times height. But when you don't know the height of a triangle and you can't find it, any triangle, okay, particularly non-right triangles, you can find the area two different ways. There's actually several different ways, but I'm going to give you two formulas. This particular long, complicated formula is called Heron's formula, and it is used when you know the three sides. Okay, if you know all three sides of a triangle, you add up the three sides, you add up A, B, and C, and then you take half of it. This is called the semi-perimeter or halfway around. And then there's this messy formula that says you take that semi-perimeter and the difference between that and each of the sides, and you multiply that all together, and then you square root it, and that's the area. Complicated. All right, we're going to do one by hand, and then I'm going to show you the shortcut on the calculator. So for this particular one, the sides are 36, 20, and 22. So the perimeter would be 30, 40, 50, 60, 78. Did I add that up correctly, guys? 20, 40, 50, 60, 78. Yes, it's the perimeter. So the semi-perimeter is that divided by 2, or 39. Halfway around is 39, okay? So then we're going to type 39 times 39 minus 36 times 39 minus 20 times 39 minus 22, or 39 times 3 times 19 times 17. Did I subtract all those right? I don't know. We'll do it, and then we will, got to remember there's a square root after all of that mess. We'll check it when I do it on the calculator the short way, okay? So we have 39 times 3, which was 39 minus 6, times 19, which was 39 minus 20, that seems okay. Oops, times 39 minus 22 seems like 17. All right, and then we need to square root all that. And my habit is to do the square root of that answer. You guys probably have a habit of just arrowing up and bringing that number down. It's just the calculator didn't used to do that, and so I haven't gotten in that habit. So it was square root of 39, what was it? Or 37, 7, oh, why, Hofbauer? 37791. Which made the area 194.4. Inches squared, because area is always square units. All right, I'm going to show you the trick, and the first time I just want you to watch. I don't want you to even try to do this on your calculator yet. The trick is we're going to store, and that button is on your calculator. We're going to store, which is right down here. Let me blow it up. We're going to use this store button. And I'm going to store my value into X because I know right where that X button is and it's easy to find. You can store it into S, it's just a lot more work. So we had sides of 36, 20, and 22. 36 plus 20 plus 22. And then we were supposed to divide that by 2. Make sure you either put parentheses around the top or you hit enter before you divide by 2. Because you don't want to just divide the 22, you want the whole thing. Now, what I'm going to do is store that answer into X. Okay, or you could just type 39, store into X. Store is this STO button, and it's going to look like this, and it's just going to say 39, but now every time you hit X, it has memorized that it's 39. And before you freak out, you don't ever have to undo that. As soon as you graph something, the X value changes, and we never use X in the home screen, so it doesn't matter. We're just going to use it now because it's going to help us type this much faster. So the rule was 39 times 39 minus 36 times 39 minus 22 or 20 times 39, but I don't have to type it. I can just do the 22, okay, minus, yes, it's so much faster, unless you're Hofbauer who can't type. All right, and then we would square root that and get what we got. All right, it seems like a lot of work, but I want to show you that when you have one like this, where the number you have to keep typing in is a decimal, storing it helps a lot. So we have 14 and 9 and 8, which totals 31. Divide that by 2 to get S, and we get 15.5. So now you could type 15.5, parenthesis 15.5 minus 14, parenthesis 15.5 minus 9, parenthesis 15.5 minus 8, and get an answer. I'm going to store that 15.5. So I'm going to say 15.5 is now being stored into my new X value. So it's no longer 39. So then I'm going to say X times the quantity X minus 14 times the quantity X minus 9 times the quantity X minus 8. And I could have actually put the square root around before that. I forgot. But I'll do the square root of that last answer. And I got 33.7. And I think it's a little bit faster than typing the 15.5 over and over and over. Okay, 33.7. And that was square feet. All right, so do whichever way you want. You can do it all out if you want. 8 plus 12 plus 13 is 33. Divided by 2 is 16.5. So you can do 16.5 times 16.5 minus 8 times 16.5 minus 12 times 16.5 minus 13, and then square root it all. I'm actually going to type it on my handheld one. I'm going to do 16.5 stored into X, and then I'm going to actually type square root of X times X minus 8 times X minus 12 times X minus 13, making careful not to miss any parentheses. And I got 46.999 or 47, just that fast. Okay. So either way, hopefully comes out the same. Yeah, I'm checking my answers here, and that's what I got doing it in my notes. All right, one more area formula. And this one is useful when you know two sides, okay? Two sides and an angle. You have to know two sides and the angle in between, but sometimes you can use the law of sines to find the right angle if you don't have the right angle. So, or even a missing side you might need. So what it's basically saying is 1/2 of a side times another side times the sine of whatever angle is in between those, called the included angle. So if we have this triangle, R is 50 degrees, S across from there is 12 yards, T, which will be across here, is 14 yards. So we do indeed have two angles in the side of the angle, or two sides and a side in between, angle in between. Try that again. We have two sides and an angle in between. So we can use this rule to say it's 1/2 one side times the other side times the sine of the angle in between. So I'm just going to type here, you can use a fraction of 1/2. I'm just going to do 0.5 times 14 times 12 times the sine of 50. And I get 64.3 square yards. That's all you got to do. All right, this one is a little bit trickier, thus the little star there. It does say we have a 110-degree angle, and I didn't draw it very obtuse. N is a 25-degree angle, so we could right away find the other side, or the other angle. Gosh, I can't say that right today. 70 minus 20 is 50 is 45, I think. Double check me. I'm gonna check my notes, make sure I didn't do anything crazy. All right, and then the side we know N is 14 feet. So I need two sides to use this formula. So I'm going to find another side. I guess I'll just find this one. So the sine of 110 is across from side P in the same way the sine of 25 was across from 14. If I type that real fast, 14 times the sine of 110 divided by the sine of 25 makes side P down here 31.13. I'm going to carry an extra place for now. So now we can use these two sides and the angle in between. So we have the area would be 1/2. One side is 14 and one is 31.13, and the other angle in between is 45 degrees. So I just type that. 0.5 times 14 times 31.13 times the sine of 45. I get 154.08 or 154.1 square feet. As long as you got somewhere close to 154, I would be all good. Okay, if you'd rounded that to 31.1 earlier, I think you would have got 154 even, which is fine. All right, last question is application. The McBiggs plan to purchase a triangular parcel of land. One side of the property is 75 feet long and forms a 38-degree angle with another side of the property. But this side is really hard to measure, okay? Maybe there's a lake or something, a little pond here, or a fence or something. The remaining side of the property over here is 95 feet. Find the approximate area of this piece of land. Well, unfortunately, we don't know the angle we want. Okay, these are across from each other, but we can find this angle down here. We want to be able to use this angle in here, because then we'll do the area is 1/2 of 75 times 95 times the sine of whatever this angle is. But first, we're going to have to find this one. So the sine of, let's see, I don't have any variables yet. Okay, I'll call this x, is across from 75 in the same way that the sine of 38 is across from 95. So if I type, I get 75 times the sine of 38 divided by 95. And then I have to do inverse sine. Now, every time I do inverse sine, I'm supposed to think, can there be two possibilities? So I got 29. If you do 180 minus 29, you get 151. Can I have a 151 if I already have a 38, guys? No, I can't, because that would be 38 and 151 is more than 180. So that means this angle down here has to be 29 degrees. And then if I do 180 minus 29 and 38, I get 113 in between these two sides, and that's going to go in here to find the area. So we have two sides of 95 and 75 and an angle in between. So 0.5 times 75 times 95 times the sine of 113 makes the area 3279.3 square feet. Okay. So they're getting just over 3,000 square feet of land. Oh, where's my answer key to that? I'll just make sure. Okay, all good.